This is day 3 of lesson 3.5. We're going to be looking at the third sheet, the third page in your 3.5 notes. Before we begin on those special cases, let's review the steps. We talked about this yesterday. Step 1 is to distribute. Step 2 is to simplify. Step 3, move variables to one side. And step 4 and 5, undo addition or subtraction. Now, what we're going to see today are those special cases. Those special cases are really these statements here. If the solution is false, there is no solution. What that means is something like 2 equals 7. Well, 2 does not equal 7. So that would be a false statement. In a case like that, that's where we would say no solution. And we'll be using the symbol for no solution. Similarly, if the solution results in an identity, the solution is all numbers. Now, what that really means, an identity, is a true statement. If the solution is true, in other words. So something like -3 equals -3. That's true. So that solution would be all numbers. And more specifically, it would really be all real numbers. There is a symbol for that as well. The symbol for all real numbers looks like this. It looks like I'm making the 2 L's in the word all. And it looks like I'm making an R right on top of those 2 L's. That symbol, again, means all real numbers. So false means no solution. True means all real numbers. So let's turn our page. That's page 2. Here's page 3. We begin with these special cases. Remember, our very first step is to distribute to get rid of parentheses. So let's begin. 2m plus 5 equals 5m minus 35, and recopy, minus 3m. Our next step is to combine like terms. On the left side, there are no like terms. However, on the right side, there are like terms. 5m minus 3m are like terms. So that gives us 2m plus 5 equals 5m minus 3m is 2m minus 35. Our next step is to move our variable. To move this 2m to the other side, I would need to subtract it. So what happens? On the left, 2m minus 2m is 0. So on the left side, you really have 0 plus 5. On the right side, 2m minus 2m is also 0. So on the right side, you have 0 minus 35. So do the arithmetic. 0 plus 5 is 5. 0 minus 35 is negative 35. The variables cancel it out. Did we know that was going to happen from the beginning? No, it just happened. So, is this true or false? False. 5 does not equal negative 35. And because it is false, that means our answer is no solution. And again, the thing about these special cases is I don't recognize that it's going to be a special case when I see the problem. It just looks like any old normal problem to me. Let's start on number 2. We get started again by distributing. This would be 3r plus 3, recopy, minus 5 equals 3r minus 2. Now we want to see if there are like terms, which there are on the left side. We can combine those like terms. That would be 3r plus, well, I'm sorry, that's not going to be plus. 3 minus 5 is negative 2. So when I write that down, it should be read as 3r minus 2. Recopy equals 3r minus 2. Now some people recognize what's going to happen already. But we know our next move is to move the variables to one side. That means in this case subtracting 3r from both sides. What happens is very similar to number 1. 3r minus 3r is going to be 0. We're left with, on the left, 0 minus 2. And on the right, 3r minus 3r is also 0. And we're also left with 0 minus 2. So finish it up. 0 minus 2 is negative 2. Negative 2 equals negative 2. That's a true statement. Since that's a true statement, our solution is all real numbers. And let's make the symbol for that, because of course in math we don't like to write out a lot of words, we like to use symbols. Remember again, the symbol looks like the two L's from the word all with an R on top. Moving on, the following problems are really just more of a tongue-tied today, more of a review from all the things that we've done in this section. So, it just looks like a longer problem, but it's not really that bad. Remember, our first step is to distribute, which we don't have any parentheses here. Our next step is to combine like terms. So let's look at each side individually. On the left side, I see that those are like terms. If I were you, I would be putting boxes or circles around these items to determine for yourself that they are like terms. So if that were me, what my paper might actually look like is this. I see the 6x and the minus 13x are like terms. I circle them. I see that the positive 8 plus 8 and the positive 10 are like terms. So I put a box around those. Let's combine those like terms now. 6x minus 13x is negative 7x. Positive 8 plus 10 is positive 18. So I simplified the left side. Let's do the same work on the right side. Let's look for like terms. Here's a like term, negative 6x and positive 4x. So we need to think about negative 6x and plus 4x. That would be negative 2x. There are other like terms with the constants. 4 minus 11, which would be negative 7. And we wouldn't write it negative 7, it would translate down to minus 7. So, we took a really long problem and condensed it down, so now it looks a little easier, it looks manageable at this point. Our next step is to move the variables to one side. We can move the negative 7x or we can move the negative 2x. It really does not matter. It doesn't matter what we do first. So, I don't know, let's just move the 2x. The opposite of negative 2x is positive 2x. So add 2x to both sides. Negative 7x plus 2x is negative 5x. So negative 5x plus 18 equals, those canceled, equals negative 7. Don't forget the sign in front of that 7 sticks with it. Almost done now. We can get rid of the negative 5 or we can get rid of the 18. And our rules tell us we must undo the addition first. So that would be subtracting 18 from both sides. This is negative 5x equals negative 25. And then lastly, divide both sides by negative 5. Don't forget that a negative divided by a negative is a positive. Positive 5. So we took a problem that looked really hard from the beginning and just worked our magic, worked our normal steps, and came out with a pretty decent answer in the end. Now, we have 2 more problems, and I have about 5 more minutes left of my time, so we'll see how far we get If we only have time for one more problem, it will be up to you as a class to finish the last one together. And number 4. Our first step on number 4 is to distribute to get rid of any parentheses. That starts off as 9x plus 27. Recopy. Minus 5x. Whoa, wait a second. Next I come to parentheses. I need to distribute to get rid of those parentheses. But what should I distribute? Be very, very careful. Because you should distribute not just a 3, but the sign in front of it also. So really, I'm distributing a negative 3. So really I've got to think about negative 3 times 5 is negative 15. And negative 3 times 3x is negative 9x. Be very careful with that. Sometimes it helps to do what I've done there and circle what you're distributing. That way you notice the sign. Okay, still we are dealing with a pretty long problem here, so let's see what like terms we can combine. On the left side, it looks like we have a like term of 9x, a minus 5x, and a minus 9x. We also have like terms with the constants of plus 27 and minus 15. So, let's take those teal things, the like terms with the variable, the x's, 9x minus 5x minus 9x. That would end up giving us negative 5x. 9 minus 5 minus 9 is negative 5. Combine the other like terms highlighted in the yellow, 27 minus 15, which would give us positive 12. And recopy equals 52. So again, just like number 3, we've taken a problem that looked really hard from the beginning, and now it looks a whole lot easier. It's a little bit more manageable. Our options are get rid of the negative 5 or get rid of the positive 12, which we know we save undoing that multiplication for last. So we're forced to undo adding 12. The opposite of adding 12 is to subtract 12 from the left side and from the right side. That leaves us with negative 5x equals 40. Our last step is to divide both sides by negative 5. And x equals negative 8. Yay! Almost done. It looks like I have about 2 more minutes of my time, so we'll see how far we get. Lastly, in number 5, we're dealing with the same scenario of distributing to get rid of the parentheses. Negative 8 times 2 is negative 16. Negative 8 times negative x, and negative times a negative is a positive 8x. Now to distribute for the second group of parentheses, again the same scenario of, don't forget, you're distributing a negative. That would be negative 4x, and negative 4 times negative 2 would be positive 8 equals 8. And so let's combine our like terms. On the left side, the like terms of the variable are 8x and a minus 4x. And then the like terms that are constants are the negative 16 and plus 8. So let's begin that. 8x minus 4x would be 4x. Negative 16 plus 8 is negative 8. Recopy equals 8. Our next step is to add 8 to both sides, which results in that's sloppy. which results in 4x equals 16. Our last step would be divide by 4. 16 divided by 4 is 4. X is equal to 4. I know we rushed through that last problem. You're more than welcome to pause the video and rewind at any time. I hope you've enjoyed this lesson. Let's have a great end of chapter test.